Okay, parents, welcome to my classroom. Today we will be going through a question paper of natural science and tech for grade 6. Welcome to my classroom. I am Sir Rudolph Mathumbu. I am a professional teacher. I hold a degree in education and I am SAYS registered. If you need revision with all CAPS aligned subjects, you are in the right place. Please subscribe for more revisions. If you need private tutoring, please contact me using the contact details provided in the description of this video. Okay, let's get into today's lesson. If you look at the question paper that we have in front of us, question 1, it's a multiple choice. It reads like this. 4 options are provided as possible answers to the following question. Each question only has 1 correct answer. So this just tells us that they have provided us with 4 possible answers. But in these 4 answers, only 1 is correct. So the next instruction says, circle the correct answer. So it does not say make a tick, it does not say underline, but it says circle. So it means we'll be circling the correct answer. Let's go to the first question and see if we can answer it. The first question says, photosynthesis is the process that plants use to change the energy from sunlight into energy for. So energy from sunlight into energy for. So we have to get the answer here. Is it the energy for oxygen? No. Then we cancel it. Is it they change sunlight to energy for growth? Do they use it for growth? No, it is wrong. But let's look at this. Is it changing energy from the sun into food? Yes, this is the correct one. Photosynthesis is the process that plants uses to change the energy from sunlight into energy for food. So that is the correct answer. Then now let us move to question number 2. So question 1.2 says, how many life processes do living plants and animals carry out? Life processes. How many? So they want a number. How many? Is it 7? Yes, 7 is the correct answer. Then 7 lives. So living plants and animals carry out 7 life processes. Ne? All right. Let's move to the next question. The next question says chlorophyll. So this is the statement. Chlorophyll has energy. Chlorophyll is a green substance that the plant uses to capture light energy from the sun. Or chlorophyll absorbs water and nutrients from the soil. Chlorophyll provides mineral nutrients and water for the plants. The correct answer is B. So we will circle B because chlorophyll is a green substance that plants uses to capture light energy from the sun. We move to 1.4. So 1.4 says, what test do scientists use to see if a food product is a starch or not? So if a scientist want to see if that food is a starch or not, which test do they use? Do they use a basic starch test? No. Do they use Ellis starch test? No. Do they use the iodine starch test? Yes, this is the correct one, because remember they put iodine on a food and then to determine if that food has starch or not. So let's move on. We move to question 1.5, and the question 1.5 says, what do all plants and animals need to carry out the life processes? What do they need to carry out all life processes? They say plants and animals. Do they need sunlight to carry out the life processes? No. Do they need carbon dioxide? No. Do they need a shelter? No. Do they need oxygen? Yes. So we circle oxygen, because oxygen is what they need to carry out the life processes. All right. We move to 1.6. 1.6 says, what state of a matter takes the shape of its container but has a fixed volume, can't be compressed? So this is a matter that we're talking about. It should take the shape of its containers, but the volume is fixed. Thinking about it, what is it? Is it solid? Solid do not change shape, so it means this one is wrong. Is it liquid? Does liquid change shapes? Yes, liquid change shapes whenever they are put in a container. If you put it in a cup, it will take the shape of that cup. If you put it in a normal container, it will take the shape of the container. So liquid is the correct answer. It cannot be gas, it cannot be plasma. So the correct answer is liquid. All right, we continue with our revision, and now we look at 1.7. Question 1.7 says, which of the following is an example of a mixture? Which of the following is an example of a mixture? Pure water, is it an example of a mixture? No. In pure water, there is nothing that is mixed there. Gold, is gold a mixture? No. So gold is not mixed with anything. Okay, table salt. Is table salt a mixture? No. Sugar and water, is it a mixture? Yes. The answer is yes. Okay. The answer is yes, because here they have mixed sugar and water. So that is the correct answer. Moving to 1.8. What happens when a solid dissolves in a liquid? So what happens when a solid dissolves in a liquid? The solid disappears completely. when you dissolve solid in a liquid, does the solid disappear completely? Does the solid break down into tiny particles spread evenly in the liquid? This is a wrong answer. This is correct. When you dissolve, for an example, sugar in water, it means the small particles of sugar, they spread evenly into the liquid. The solid sinks to the bottom? No. The liquid turns into a solid? No. So the correct answer is B. All right, let's move to 1.9. So 1.9 reads, which of the following increases the rate of dissolving? So we want something that increases the rate of dissolving. What is the correct answer here? A, using large solid pieces. When you use large solid pieces, does it increase the rate of dissolving? No. It means this one, it is wrong. Lowering the temperature. So if you lower the temperature, does that increase the rate of dissolving? No. So that one is it's incorrect. All right, let's look at C. Stirring the solution. Okay, let's say we have got tea and we put sugar in the tea. When we stir the tea, does it increases the rate of dissolving? The answer is yes. So C it is. So C is a correct the correct answer. Keeping the water still does not increase the rate of dissolving the liquid. We move to question 1.10, which is the last question. The question says, what is the term? So it means here they want a term for a solution that can no longer dissolve any more solute. So this one can no longer dissolve. What is the term? Is it dissolute? Is that the correct term? No. Is it saturated? This is a correct one because the saturated solution can no longer dissolve any soluble. When it is saturated, it means it is no longer able to dissolve other solutes. So now let's move to question 2 and try to answer questions. So question 2 is about completing the sentence. It means we just complete the sentence. We put what is missing in the space that they have left there. Okay. Is a combination of two or more substances that can be separated physically. What is that? What is it that it is a combination of two or more substances? What is it? We are talking, when we combine something, it means we mix, right? So this, a mixture is a combination of two or more substances that can be separated physically. All right, let's move to 2.2. When salt is added to water, and disappears, it forms a what? We are talking about salt here. We add salt to what? To water, and it disappears. When it disappears, what does it form? What is it? Remember, we spoke about solution when, like on the question that we answered in question 1, there was a question that asked us about solution. So if we mix salt and water, we have a salt solution. But here they just want one term, which is solution. All right, 2.3. The process of separating clean water from dirty water is called what? So we separate. They want a process of separating clean water from dirty water. What do we call it? What do we do if we separate clean water from dirty water? We purify, right? So the process of purifying water is called purification. So the process of separating clean water from dirty water is purification. All right, let's go to 2.4. 2.4 says the three main states of matters are. Remember matter? Now we want 3 states of matter. Can you think of any? Remember, matters, we have got solid. So a solid like this table, it is a state of matter. Then we have got what? We have got liquid. Water, oil, and paraffin are what? A liquid. Ne? So that is the state of matter. All right. The last one is what? Gas. So gas is the third state of matter. Like water, water can be solid because ice is water, but now it's solid. So you can melt the water and they tend to be liquid again. And then you boil it, they tend to be a gas in a form of vapor. So that's how you can remember the 3 states of matter. All right, let's move to look at question 2. Let's move to look at question 2.5. 2.5 says, the speed at which a substance dissolves. So here we speak about the speed at which substances dissolve in a liquid can be increased by doing what? How can we increase the speed at which substances dissolve in liquid? So they want 1, 2, 3 answers. So the first one, we can heat. We can use heat. We heat the liquid like boiling water. Remember when you make tea, sugar dissolves quickly in hot water than it would in cold water. So heating increases the rate at which substances dissolve in liquid. It increases the speed at which substances dissolve in a liquid. Another one is stirring. Stirring. When we stir the sugar in our tea, we are increasing the speed at which the substances dissolve. Ne? So the last one is breaking it into smaller particles. We breaking it into smaller particles. So, or into smaller pieces. When we break it into smaller pieces, then it dissolves faster. Okay, let's move to question 2.6 there. So question 2.6 says, in an ecosystem, living things interact with each other and with factors such as water, soil, and sunlight. So living things interact with each other, but not only that, but they as well interact with non-living. So in an ecosystem, we find living things and non-living things. So they interact with non-living factors. These are non-living factors such as water, soil, and sunlight. This we find in an ecosystem. All right, let's move to question 3 and we'll see how can we answer it. So question 3, dissolving and the rate of dissolving. Okay, let's look at the first question. 3.1. What does the term dissolving mean? The term dissolving, what does it mean? So what does the word dissolving mean? So dissolving, let me write, dissolving is the process where a solid breaks down into tiny particles and spread evenly throughout a liquid to form a solution. So this is the answer. The word dissolving is the process where a solid, which can be sugar, it can be salt. So a solid breaks down into tiny particles and they spread evenly. So we go to 3.2. 3.2 says, name 3 factors that affect a rate of dissolving and explain how each factor influences dissolving. Remember, we spoke about heating. What is heating? It's temperature. It is temperature. Remember, temperature is how hot or cold. So, temperature affects the speed, because here, when we speak about the rate of dissolving, we speak about speed. So, temperature, remember that temperature, when we speak about temperature, we speak about hot or cold. So this temperature can affect the way dissolving takes place. Because when it is hot, solids can dissolve faster. And when it's cold, the dissolving can be slower. All right. They say they wanted a tree, and that is one of the tree. The second one is stirring or shaking. You can say stirring or shaking, because if you have it in the bottle, then what are you going to do? You will just shake the bottle. So it's stirring or shaking. If you don't stir the solution, then it means the solids that you have put there will not dissolve quickly. But if you stir them, they will dissolve faster. Okay, the last one is the size of the size of the solids. The reason your sugar is very fine, it's because it will increase the rate at which it dissolves in tea. But imagine if 1 grain of sugar was a one big solid rock, maybe of a size of your fist. Do you think it will easily dissolve in a tea? No, it wouldn't. So that is the reason they break it down into finer grains. Even our salt is broken down into fine grains, so that when you put it in your meat or anything that you are cooking, it dissolves faster. So these are 1, 2, 3 factors that influence the rate at which your solids dissolve, or the speed of dissolving. It's influenced by these 3 factors. Let's move to question 3.3. Okay. 3.3 says, if you put a sugar cube into a cup of cold water and another into a cup of warm water, which will dissolve faster? Okay, think about it. You have got a cube. A cube is something like this. A cube, my drawing. Yeah, I think it is. A cube is something like this. So if you have got a cube of sugar, you put one into cold water, they say. Cold water. And you put the other one in warm water. Which one do you think will dissolve faster? That's what they are asking. So, thinking about it, you must know that the sugar in the warm water will dissolve faster. So the sugar in the warm water, okay, will dissolve faster. Now I've already messed up my space. So the sugar in the warm water will dissolve faster because of the temperature. The temperature is a bit increased compared to the cold water. So this one means that the temperature is a little bit high, and that increases the speed. So the heat, remember we already spoke about this, the heat increases the speed at which this water will dissolve. So because of the heat, the movement of water molecules, it's increased there. So they move faster. The water molecules in a warm temperature, they move a little bit faster. And because of that, it increases the dissolving, because it allows the sugar particles to spread out more quickly. Né? So that's how you can explain your answer. We move to question 4. Question 4 says, draw and label a simple diagram showing the arrangement of particles in a solid state, liquid, and gas. So, okay, in a question like this, where they say you draw, so you draw and you label a simple diagram where you show the arrangement of particles in a solid state. So one, we will be doing solid here, and then the second one is liquid. So the last one is gas. So here you just show the particles. So the particles can be represented by tiny little things. So these can be the little particles that are very compressed against each other. So at the same time, like the particles that makes up a stone or a rock, they are closely tied to each other to the point that they are very much tight. And then a stone that has got the particles mounted to one another. So, but when you come to liquid, the particles in a liquid, they are a bit like this. They have got a space amongst them. So they are spread evenly. These particles are spread evenly. Yeah. They are not as tight as these ones, because in a solid, the particles are very tight, but here they are more, they are slightly spread out, but they are still touching each other here. When we come to gas, here the particles are far apart. The particles in a gas are far apart. They are moving freely. So you can see the difference here. The particles are fixed to each other. They make up a stone. Here, they are a little bit spread. They are a little bit spread evenly. They okay, let's just say they are spread out. They are slightly spread out. These ones, they are far apart. So the particles here are fixed against each other. The particles here are spread out, slightly spread out, but the particles here, they are far apart from each other. We move to the question 4.2. So 4.2 says, explain how the arrangement of the particles in a solid differs from the gas, for 2 marks. So you explain how the particles from solid differs to how it differs from gas. So okay. Here, the arrangement of the particles in a solid and a gas, they are like this. Imagine you have got an ice cream. So an ice cream is an ice, which means that the particles here are fixed to each other. They are fixed to each other. But if you add energy here in a form of heat, if you burn this ice cream, it will turn into liquid. And now in a liquid, we said the arrangement here starts to spread out. If you continue to burn it and boil the liquid, now it turns into a gas. So the gas now, because now you have got a vapor, the water vapor. So this water vapor, now here, the molecules or the particles now are far apart. Far apart. So the difference, they say you must explain how the arrangement of the particles differs from a gas. Solid differs from a gas. Is that the arrangement in a solid, it's fixed. The particles are fixed against each other. But here on the gas, they are far apart. They are far apart. They are not attached to each other. They are not fixed, but they are far apart. Let's go to 4.3. 4.3 says, give one example of a substance that changes from solid to liquid and explain what causes the change. So the example that we have, we're going to use its ice. Ice, we know, if we all know ice is solid. And then, if you heat, it goes back to what we have already said. If you heat ice, it will melt. And when it melts, it turns to water, which is liquid. It turns to water. See, this is liquid in a cup. So this is liquid. The water that we can drink is liquid. So if you continue to heat, you heat again, you continue to heat the liquid, and it reaches the boiling point. Now you heat the water. It reaches the boiling point. The water starts giving off water vapor. So this is water vapor. Water vapor is now in a form of gas. It's now in the form of gas. So the heat is the energy that helps this substance to move from a state of solid to liquid, from liquid to gas. So that is how you take an ice from a fridge. It's very cold, but when you start heating it, it melts and turn into liquid. If you continue to heat the liquid will start boiling and it will turn into water vapor. So the water vapor is now a gas. We move to question number 5. So question number 5, it speaks about food processing and nutrition. 5.1 says, why do we need food processing? Why do we need food processing? Why do we need to process food? What will be your answer? So, food processing helps us to preserve food. Food processing helps us to preserve food. We preserve it. It means when we preserve a food, now it means that we can keep it a little bit longer. Like, okay, let me see the example of a processed food. You take a mango, you process it into a juice, and now you can keep that juice in a refrigerator for a long time. So you have preserved the fruit, you have preserved the juice of that fruit for a long time. So that is the reason we need food processing. It makes us to preserve a food, and it makes the food safer to eat, and it improves its taste. Because, okay, some of these food, when they preserve them, like juice, you find that they add sugar to it, they add flavor to it, or that improves the taste of that food, and it improves the texture. Sometimes the texture, it can be thickness. Some juices, you find that they are thin, some they are thick. So that is how what it improves. It improves taste. It helps the food to be a little bit thicker. It helps the food to be safe. We can keep it for a long time and it is safe to eat. So that is the answer of 5.1. Let's move to 5.2. 5.2 says, describe 2 ways in which food is processed to make it safer to eat. We just need to give 2 ways that we think food is processed to make it safer. The first one that we know is canning. Canning. So this is the way that processed food is made to be safe to eat. Canning. Canning simply means putting the food in a can. Which food do we have that we have put in a can? You can think of fish. You can think of beans. You can think of juice, as we already spoken about juice. They are food. They are juices that are in cans, isn't it? Okay. The second one, it's sun drying. I'd like to believe that you have come across fruits that were dried in the sun. Fruits. This kind of fruits, you can find them in your supermarket today. You'll find they call them dry fruits. Dry fruits. So they put these dry fruits in like in the sun, and they dry. And when they dry, now you can keep them for a longer period of time, and they are still easy. They are still safe to eat. See? So unlike if you take mango and you don't put it in the sun, you keep it in your fridge, you find it reaches a time where you can no longer eat it. But if you turn it into a dry fruit, you give it a long life. All right, let's move to question 5.3. Question 5.3 says, explain what happens if a person does not eat a balanced diet. If you do not eat a balanced diet, what happens? So give 2 examples of diseases caused by, so they want examples of diseases caused by unhealthy diet. So first they want to know what happens if you do not eat balanced diet. Can you think of one thing that can happen if you do not eat a balanced diet? Number 1, if a person does not eat a balanced diet, they may become malnourished. Malnourished. This means that you do not have enough nutrients that are needed by your body. So you become malnourished. And you can become weaker. You become weaker. I know of people whom were told that their bones are weak because they lack the nutrients that makes bones to be stronger. So another thing that might happen is that the people might suffer from health problem. The other issue is that they may suffer from health problems. So you find that you become sickly because of not having a balanced diet. So the second one says that discuss the diseases that are caused by unhealthy diet. Okay, the first one, obesity. Obesity is the diseases where you gain weight and you become heavier in an abnormal way. And that can be caused by unhealthy diet, which means that you are eating a lot of fatty food. And because of that, you just continue to gain more weight. Another diseases can be diabetes. Yeah. So diabetes is the sickness where the blood sugar it's either high or low in your blood. Another one Unhealthy diet as well can cause tooth decaying. So you find you eat a lot of sweet stuff and then you end up with decaying teeth. There's a lot of diseases that we can put in there that can be caused by an unhealthy diet. But let's move to question number 6. Question number 6 is about water purification and the ecosystem. Question 6.1 says, why is clean water important for humans? If you may answer that question, why do you think clean water is important for human? Okay. Clean water is important because it prevents, clean water prevents diseases. If we drink clean water, we will not catch diseases and become sick. And this will keep our bodies, it will keep our bodies healthy. It will keep our bodies healthy. So, and water is essential for survival. If we didn't have clean water, then it means we will not survive in this earth. So water is very much important to humans because it prevents them from diseases, it keeps their body healthy, and it helps them to survive. 6.2 says, describe 2 ways in which water can be purified. So they want 2 ways in which water can be purified before drinking. What are the ways that you think it can be used to purify water? The first one that comes to your mind, it should be boiling. Boiling. So if you boil water, even if that water was dirty, even if that water had germs, the germs will die. The germs will die. And when the germs are dead, the water will be safe to drink. So that is one of the ways that we can use to purify water. And the other way that we can use to purify water is it's a filtration. So filtration is where we use filters to remove the dirt or the impurities and impurities. So here we use what? We use filters. So it means your water goes through a filter. If you have got a tap of water coming this side, it goes through a filter. It gets to be filtered here. So like it was dirty this side, but through a filter now it becomes clean. So this is the other way that we can purify water. All right. The very last question of our question paper is 6.3. 6.3 says, explain how waterlands helps in cleaning water naturally. All right. Waterland act as natural water purifiers because they can absorb. They are natural water purify. It is purifiers. And that is because they absorb soluble and insoluble impurities. So they absorb them from the water, and they regulate water flow as well. Waterland, they regulate water flow across the landscape. So as well, waterlands helps clean water by trapping. They trap pollutants. So they trap pollutants as well in the soil. So they filter as well harmful harmful substances, and they allow the plants to absorb excessive nutrients. So that's how you would answer question 6.3 about how wetlands helps in cleaning water naturally. Thanks for watching this video up until this point. It shows that you are serious about your education. Remember, if you want to learn something, repetition is the mother of all learning. So it is very important that you keep on repeating this video until you grasp all the concepts that I explained here. If you feel that there are some things that I didn't cover in this video, please do not hesitate to put it in the comment section.